So we've been adding fractions with different denominators, and now we're starting to think about mixed numbers. Now, the last question was asking the answer to be done in a mixed number. It says 43 over 33. What is a mixed number? It's something like this, or this, or this, like 1.5, 6 2/3, whatever else it might be, where you have a whole number and a fractions together. If you don't write it as a mixed number, if you write it just as one fraction like this, we call this a top-heavy fraction because the top is bigger than the bottom. So if we think about what a fraction really means, when I write 43 over 33, I mean I've taken an object like this, for example, and I've chopped it into 33 bits. And then the number at the top is like how many of those bits are we talking about here. So if I talked about all 33 bits, that would be one whole object, whatever this might be. So therefore, if this number at the top is larger than the number at the bottom, that'll be more than 1. So that's how we know we've got a top-heavy fraction, and that's how we know we could, if we wanted to, write it as a mixed number. So how do we write it as a mixed number? Well, we take the 43 over 33 and we chunk it into 2 bits. We take the 33 over 33, which we now know is obviously 1. And how many more bits do we have left over? Well, 43 minus 33 would be 10. So we have 10 bits left over, 10 33s left over, 10 33rds. So the 33 over 33 changes into 1, as we said. That's all 33 bits. And we've got another 10 33rds, maybe from another object, right? Imagine I take another one and I chopped that bit into 33 bits as well, and I've got 10 of those bits. So I've got a whole thing, and then 10 33rds of another one. So I'd write it like that. So in the next few questions, I'm just going to go through question 7. We're having to do the reverse. They give us the mixed number. What we're going to have to do is turn it into top-heavy fractions, and then we're going to have to change the denominator so as they're both the same denominator like we've done with all the other ones. And then we can add them, and then we're going to change it back into a mixed number because we want the answer to be in a mixed number. So let's have a think about how we do this. Well, first of all, use these diagrams which I've drawn here. So we've got this will be a whole object. I've chopped it in 2. And I've got 1, 2, and it's a 2.5, and then a half of another one. So this represents the 2.5 fraction. And then I've done the same with the green 1 2/5. So we've got a whole thing there. That'll be the 1. Then I've chopped it into 5 bits, and I've chopped another one into 5 bits, and I've just got 2 of those 5 bits. So looking at that diagram, I can see that 2.5 is the same as 1, 2, 3, 4, 5 halves, or 5 over 2. Okay, and 1 2/5 is the same as 1, 2, 3, 4, 5, 6, 7/5. So how could I have done this without drawing the fractions? The same sort of way as I did earlier on. We know that well, let's just write it here. 1 2/5 is just 1 plus 2/5. And I know that 1 is going to be 5 over 5. And we've still got the 2 over 5. So that's 7 over 5. As we can see, this is the same as this. Okay, so this time I'm kind of doing it more thinking about the numbers, but you can kind of like use whichever method you want. You can do some bits in your head. You don't have to do it all. You don't have to write all the steps down. You can. I would suggest if this is new to you to write all the steps or write more of the steps down, and as you get quicker and quicker at doing this, then you start to do some of the steps in your head. But what I would say though is as you're going through them and you're speeding up the process, to never lose track of the intermediate steps. If you start bounding along, doing it on autopilot, you will start to make mistakes. So whenever you feel like you're going too fast and you feel like you don't completely know what you've done, just slow down, go back over those steps. When it comes to more intense practice, you can speed up and go as fast as you like, and then mark it, see if you got them all right. But just beware of that because that's how mistakes happen. So we did the same thing with the 2 over 2.5. We can say that 2 and 1/2 is the same as, well, I take the 2. Well, this time it's not 1, is it? So it's not 2 over 2. What it in fact would be 4 over 2. 4 over 2 would be the same as 2. And then the half is just, well, it's a half. So that's what we can see here, 1, 2, 3, 4. You could, if you wanted to put 2 over 2 plus 2 over 2 plus 1/2, whichever way helps you to see it more clearly. I add the two numerators, I've got 5 over 2. So now we've got the two top-heavy fractions, so that's going to be 7 over 5 plus 5 over 2. So just to make sure we follow all this, that's the one there, and that's this one here. Now we've still got two different denominators, but from here we treat it the way we treated the other ones. So it was just converting into a top-heavy fraction first. That's the first step. Now we just need a number that they both go into, 5 and 2. So they both go into 10. So so it's going to be rewritten as something over 10 plus something over 10. And, well, what did I need to multiply the 5 by to get to 10? I need to multiply it by 2. So these things can help at the beginning when you're getting the hang of this. And I multiply that by 2 as well. And so 7 by 2 is 14. As you can see, the number at the top is bigger than the number at the bottom, the same as this. This one I'm not going to write the curly arrows, we're just going to visualize them. To go from 2 to 10, I multiplied it by 5. So I multiply it to go from 5. I need to the number I put up here has to also multiply by 5. So 25 over 10. Right. So we've got 14. Let's add that intermediate step, which is quite useful to see. 14 plus 25 all over 10, which is 39 over 10. Can that be simplified? No. 39 can not be divided by anything that 10 can also be divided by. 10 can only be divided by 2 or 5, or 10, of course. 39 can not be divided by any of those numbers. So that's the simplified answer. We need to put it as a mixed number. So 39, I'm going to chunk that into 30 over 10, because I know that 30 over 10 will be 3. And then I have the leftover 9 over 10. 30 over 10 is 3, as I said, and then we've got 9 over 10. So 3 and 9/10 is the final answer. Let's visualize that with these pictures up here again. So we already said that that's 5 over 2. I'm going to just pause the video, and basically what I'm going to do is chop all these bits. So I'm going to kind of do this. I'm going to do that, only more neatly. So I'm going to just stop the video and do that now. So as you can see, this is just the same as that, right? But now we can say that whilst it was 2 over 2, we can also say it's 10 over 10. Okay. All right, I'm going to pause the video and do it with the rest of them. I'm also going to split this one down the middle so as we can see that that will be the same as that. Okay, so now we've got them all chopped into 10 bits. So you imagine before we were trying to share this cake, maybe, well, let's say one of the cakes amongst 5 people, and then another 5 people turned up. So we take each of the 5 bits and we chop it in half. Each one chop it in half, and then split the whole thing down the middle like that, and then you've got 10 bits. And equivalently, you do the same there. You can see that this is now the same as that. So we can see that 5 over 2 is the same as 10, 20, 25 over 10, which is what we said there. Okay, let's highlight it again. Okay, won't bother highlighting that 25. Highlight that one as well. And you can also see that this is the same as 14 over 10. So then we just added them together. Now let's actually add them together visually as well. Well, we can just count them all up, can't we? Just count all the bits up. So we've got 1, 2. In fact, we can do it to make the whole number, to make the mixed number as well, right? Let's get rid of these empty bits here now. We've got 3 bits, 3 holes, and then we've got nearly another hole, 9/10 of the next one, right? Which is what we've got, which is what we've written there. Okay, so it all makes sense.